Hi, welcome to our new unit, Unit 3, and Unit 3 will be dealing with linear functions. So for our first lesson, we're going to be dealing with linear equations and intercepts. So basically everything you've done with linear equations in the past unit, we're bringing it into this, but adding a few more things to it. So objective today is how do we identify and graph linear equations, intercepts, and zero. And just in case you hear noise in the background, they're just doing work on the porch. So again, sorry for the noise. Alright, so a linear equation is an equation that forms a line when graphed. The standard form for a linear equation is ax plus by equals c. So for example, if you see an equation written as 5x plus 4y equals 8 or whatever form like this, where you have the x and y on one side and then coefficient by itself on the other side, that's the standard form. Ax and by are the variable terms. So these are terms and they have variables in it. The c is the constant, which is the number without a variable. As you can see, 8. So it's a number that stands alone. So a, b, and c must be integers with a positive. So this will have to be positive. It doesn't matter if b is negative or c is negative, but as long as a is positive, that's the format for it to be standard. And a, b, and c must have a GFC of 1. GFC is greatest common factor. So that means you can't have any other number going into it when you break it down. Alright, so for the first part, let's identify A, B, and C. So we got the first example. First, is it written in its standard form? Yes. So then we can determine the A, B, and C. So A is C, B is 2, and C is 5. Next example. Is this written in standard form? Yeah. Even though you don't see the y, at least as long as the x, the variables are on one side, and then the number that stands alone, which is the coefficient, stands on the other side by itself, then you are in the standard form, even though it's x equals -7. So with that, you could also write it as this, 1x plus 0y. The y is not there, but because it was multiplied by 0. But still there was a 0 there. So that means your A is 1, your B is 0, and your C is -7. So always remember that. If there's no y or x, assume that there was a 0 in front of it in order for it to disappear. Because 0 times whatever, a variable number, is 0, and you can always leave that 0 out. Alright, so it says determine if each equation is a linear equation, and write the equation in standard form. So the first thing we need to know, is it a linear equation? So based on what we learned in the last unit, in order for an equation to be linear, what must be true? So you've seen this form, that y equals mx plus b. So if you have the y by itself equal to mx, so there's a variable, there's a number in front of the variable, and then you have the b, the y-intercept, then it is a linear equation. So yes. Now once it is in its linear equation, turn it into a standard form. So yes, it is a linear equation, and then we have to write it into this form, ax plus by equals c. So now, whatever we have, which was the original, we're going to add 3x on both sides. And then we're going to have 3x plus y equals 4, which is in its standard form. Now, example 4. Is this linear? What do you notice? We've got two variables together. Is it like this? This d stands for a number, not a variable. So no, it's not a linear equation. Anytime you see, let's say, two different variables, then you see an extra one, then you know it's not going to be linear. Alright, next one. Determine whether each equation is linear. If it is, put it in standard form. So we look at this. Yes, it is in linear. It's a linear equation. Now we need to write it in its standard form. We need to get the x and the y together one side and the 5 by itself. So, oops, move that. So this, again, the a has to be positive. So I would choose this one. X minus y equals 5. So I'm going to take that out. So this one, so the x minus y equals negative 5. The a has to be positive. All right, let's look at the next one. Is this a linear equation? Yeah. And then we need to write it in its standard form. So when we do that, we will have 2x minus y and then negative 3 on the other side. I mean, positive 3 on the other side. So basically, if you took the, if you brought the, actually what I did was I did the y minus y on both sides and then added 3 on both sides and get into this form. And yes, it's supposed to be positive, so I'm going to do the next step. So if I have to turn out to a positive, I'm going to divide negative on both sides. So that will give me 2x, that's small, 2x, and then plus y, space that out, equals negative 3. And I'll take this out. And there you go. So you have 2x plus y equals negative 3. Next one. Is this a linear equation? Yeah, it is. And then if you write it in standard form, you would have to bring the 6 to the other side and then get rid of the negative, which I did not do. So let's do that. So that's means once I do negative 1 on both sides, I'll get positive 4. And then I'll have 4y equals 4. And let me try to, if you wanted to write it as a true standard form, you would have 0x plus 4y equals 4. And I'll put or. So either way is fine. But be careful. I mean, you see this, and then you want to divide the 4 on both sides and get the y. We need this to be in a standard form. We have an ax plus by equals 4. So leave it like that. Next one. Is this a linear equation? Yes. And it's already written in a standard form, so we're good. Is this a linear equation? What do you notice about it that is different from the linear equations you've seen? We don't have this y squared. This is part of a quadratic formula, so it's a quadratic equation. Because anytime you see a square, you're dealing with this type of equation. Let's look at the other one. Yes. And we need to write it in standard form. And I'm going to change that because you're going to divide negative 1 on both sides. So this would become positive, this would be negative, and this would become a positive. And that will be your standard form. Alright, so a linear equation can be represented on a coordinate graph, as you can see here. The x-intercept is the x-coordinate of a point at which the graph of the equation crosses the x-axis. That's the horizontal line. So you see that line where it crosses that x-axis is the x-intercept. The y-intercept is the y-coordinate of the point at which the graph of the equation crosses the y-axis. So that's the horizontal line. So if you look at the graph, that point is where it crosses the y-axis is the y-intercept. So it says, what do you notice about the other coordinate and the intercepts? If you look at these two, what do you notice? If you said that there's zeros, yeah, the other coordinate point is 0. So when you're doing the y, you notice your coordinate form is xy. If it's the y-intercept, then it'll be 0 and whatever the number is. If it's the x-intercept, it'll be the x value and then comma 0. Okay. So how many x and y intercepts can a linear equation have? Just by looking at the graph, how many can each of them have, the x and the y? If you said 1 for each, good. It is, there can only be one x-intercept and only one y-intercept. The exceptions are if y equals 0, because every point is an x-intercept, and if x equals 0, because every point is a y-intercept. So if you look at this graph, if you have x equals 0, then y equals 0, then y equals 0 is going to be horizontal. Remember when we learned about the different types of lines, so like slopes? This is our horizontal slope, and then we got the vertical slope, the undefined line, which is x equals 0. So notice that with y equals 0, each point is an intercept, an x-intercept. And with x equals 0, which is going horizontal, the red line, it touches every point on the y-axis, so it's a y-intercept. That's the only exception. Otherwise, when you have regular lines like this, which has a slope, positive and negative slope, there's only one x-intercept and only one y-intercept. So just remember that. Okay, so now we're going to find the x and the y-intercept of the line graph below. So we have the graph. Let's look at the x. So it's touching 20. So it's going to be 20, 0. Because if you were to tell this person, whoever, where is this point located on the graph? You would tell them it goes 20 to the right and then 0 up or down. It doesn't move. So it's 20, comma 0. And then for the y, you had to go up first. First you had to go left or right, but you can go left or right, and then you go up. Since the 0 is where you started, and then you go up 30, so 0, 30 for the y-intercept. So y-intercept is 30, and x is 20. The graph below shows the cost of a gym membership, and the x and the y-intercept of the graph. So let's look at the graph. What is the x-intercept? Is there an x-intercept? No. But is there a y-intercept? Let's see, this is the y-axis. Yeah, 150. So x-intercept, there is none. Y-intercept is 150. Alright, let me make this bigger. So it says how to graph linear equations using the intercepts. First one, find the x-intercept by substituting 0 for y, and then write the x-intercept in coordinate form, which would be whatever you find for x, comma 0. And then find the y-intercept by substituting 0 for x, and write the y-intercept in the coordinate form. So you have 0 for the x, comma whatever you found for the y-intercept. And then plot the points on the graph and then connect them. So we're going to do example 6 based on that. So it says graph 2x plus 4y equals 16 using x and y intercepts. So for this one, you don't need to turn it into the slope intercept form, the y equals mx plus b. All you have to do is, okay, you're looking for the x-intercept, you know that your y has to be 0. So, oops, do this first. So, you're looking for the x-intercept. That means if that's what you're looking for a value for the x-intercept, your y has to be 0. So you use this, the original, what they gave you, plug in the 0 for the y, and then solve, and then you find that your x is 8. So that means your x-intercept will be 8, comma 0. Now for the y, since you're looking for the y-intercept, let's move this down. And let me scroll this up. So for the y-intercept, you're looking for a value for y. So the x has to be 0. So you plug in your 0 for x, you solve, and then you find your y-intercept, which is 4. So since this is the coordinate form x, y, you had x as 0, so then your y, as you found, was 4. So since you have the y and the x-intercept, you have both coordinate points, then you can plot it on the graph. As you can see, the y has blue and the green, the x has purple. You plot those 2 points and then you connect them, you make your line. Since this is a line, you need arrows in both ends, and then you label your graph. And there's the line showing the y-intercept and x-intercept, and using this equation. So again, remember, if you're looking for the x-intercept, you have to plug in y as 0. And then vice versa, if you're looking for the y-intercept, you have to plug in your x as 0. Okay, let's go on to the next one. Expand this. So graph each equation by using the x and y-intercept. So now we look at this. We're looking for the x-intercept. So I'm going to put this in blue. So my y has to be 0. So I'm going to use the equation that they gave me so I can solve for x. So I plug in 0 for y, and then I start solving. This is going to be 0. And then I'm dividing 1 on both sides, -1 on both sides. So my x will equal -3. So then my coordinate form will be -3, 0. So I'm going to plot that, -1, 2, 3, 0. Okay, so I got my first one. Now for my y-intercept, my x has to be 0. Extend this page. So I use the same equation, and I'm going to make my x 0. So I'll just write that over here. So x negative, and then I'm solving for y. This is just 0. So then I'm just going to divide 2 on both sides. And this will equal 1 point. So if I do 3 divided by 2, I'm going to get 1.5 as my y-intercept. So I'm going to put 0, 1.5 as my coordinate. So now I'm going to look for this on the graph. So 0 and then 1.5 is right here. Then I'm going to make my line. I'm going to go back and use the line over here. Put the line. Okay. So I got that. Go back, fill this bigger, and then hit my line. So make sure I have it connected. Okay. And then I have to put my other arrow, and then I'm going to label it, which was, and I put that in red, so that way you know that you need to label it. So it's -x plus 2y equals 3. So I have my 2 points, the x-intercept, the y-intercept, the line, arrows, and my label for that line. Right. So go back in case you can see it. Again, if there's any time during this video that you are still confused, you can always email me or go back, pause, go back, and go slowly to see what's going on. Alright, so for this one, it says y equals -x minus 5. So in order to find your x-intercept, I'm going to use blue. I could turn it into the standard form if I wanted to, but I'm just going to plug it in. Use this and then plug it in. So for my x-intercept, my y has to equal 0. So then this would be 0 equals -x minus 5. I'm adding 5 on both sides. So then I have 5 equals -x, and then when I divide 1 on both sides, this will give me x equals -5, and I'll have -5, 0. So I'm going to plot that first. 1, 2, 3, 4, 5, 0. Now for my x-intercept, I need to make my x equals to 0. So I'm going to do y equals, and this is going to be just x, so x times negative, just 0, and then this will be -5. So then this will turn into 0, -5. So I'll go 0, and then 1, 2, 3, 4, 5. Now I'll do my line. Make sure that I connect the two dots. I'm going to do my arrows. And then I'm going to label it y equals negative x minus 5. So I'm going to have y equals negative x minus 5. And there you go. Keep that there for a while. Okay, next one. So for this one, same thing. Let's go back to blue. Looking for the x-intercept. Y is equal to 0, so 0 equals 4 plus x. Subtract 4 on both sides. And then my x will equal negative 4, so that means my coordinate is, oops, that should be negative 4, 0. I went too fast. So negative 4, 0. Then for my y-intercept, my x is equal to 0. I'm solving for y, so then y equals 4 plus 0, and then y equals 4, and then my coordinates will be 0, 4. So for the x-intercept, negative 4, 1, 2, 3, 4, 0, and then the y is 4, 0, 4, 1, 2, 3, 4, 0, 4, and then you put the line, connect the dots, draw a line, make sure you have your arrows, and when you draw your line, make sure your line is a little bit longer. What I have is good, but if you just have a small one, I don't like nuggets. I call them nuggets if they're small little lines. Try to extend them as best as you can. What I have here is good enough, but make sure it's not anything smaller than that. So then you have y equals 4 plus x. Right. And then the next one. X-intercept, y is equal to 0. Plug in 0 and then solve for x. So this will be just 0. 3x equals negative 6, and then you divide 3 on both sides. And then you're going to get x equals negative 2. So that means it's negative 2, 0. And then for your y-intercept, you're going to plug in 0 for x. So you got 3 times 0 plus y equals negative 6. So then y will equal negative 6. And your coordinates will be 0, negative 6. So you got 0, 1, 2, 3, 4, 5, 6 for your y-intercept, and then your x-intercept will be negative 2, 0. You do your line. Make sure you have your arrows. Draw the arrows. And then you label your line, so I know what line you're using. Even though there's one, you gotta label it. And that's it. Alright, so that was plotting, that was trying to find your x-intercept and your y-intercept and plotting it on the graph. So just as a recap, what we did, standard form. So in order for you to write a linear equation, you know the linear equation is y equals mx plus b, but its standard form is ax plus by equals c. So if you have 5x plus 4y equals 8, that's the standard form. That means all the variables are on one side and the number is on the other side by itself. The a has to be positive. That means no negative in front of it. So we did examples of that. In linear equations, involve just one y and one x. You don't have like double x's or a variable that is together. That is not an example of a linear equation. And if there's a square in it, it's also not a linear equation. If you just had something that was like y equals 6 or x equals 7, then, like y equals 6, that is a linear equation. There's x-intercept, y-intercept. X-intercept is where the graph crosses the x-axis, which is a horizontal line, and the y-intercept is where the line crosses the y-axis, which is the vertical line. Remember, there's only one intercept and one y-intercept. The only exception is if you have x equals 0 and y equals 0. And in order to write it in coordinate form, so for example, if you have the y-intercept, it would be 0, 30, because remember this is your x and y. So whichever is 0, then you'll have the other value as x or 0. So this one would be 20, negative 0. So remember, you have to put that in that form when you're dealing with x or y intercept. And also when it comes to graphing it, if you're looking for the x-intercept, plug in y as 0. And if you're looking for the y-intercept, plug in x as 0. Alright, so if there's any questions, you know that you can email me or re-watch the video more slowly to understand. And yeah, so that's it. So this ends our lesson. Have a good day.